This webcast discusses resistance. Resistance of a component is how much it resists the flow of current. And the resistance is a function not only of the material that an object is made from, but also of its geometry. So there's this relationship which we can use to calculate the resistance of a component. The resistance R equals the resistivity, which is represented as a rho, which is the Greek letter rho. That depends on the material. It's a material property that you will have to look up or be given. And notice that the resistivity is measured in ohm meters. Okay, so the resistance is proportional to that resistivity. It's also proportional to the length of the component in meters, and it's inversely proportional to the cross-sectional area. Okay, let's just do a little sketch to make sure that we understand the idea of the length and the area. If the current is flowing in this direction, and I've drawn a component that has a cylindrical shape. It does not have to have a cylindrical shape, but I'll just show it as an example. The length is the dimension in the direction that the current is flowing through the object. So here, I'm bringing a wire into this side and I'm bringing a wire out the other side. So it's flowing through the length of this cylinder. The cross-sectional area would be the area of the face that the current is coming into. So the area would be, for example, this circular cross-section of this wire. So looking at this equation, you can see that as the length gets bigger, the resistance increases. It gets harder for the current to make it through this component if it has to go a longer way through the component. But as the area gets bigger, the resistance actually gets smaller. And that's because as the area expands, it's easier to fit through the component, so the current doesn't have as hard a time moving through. Okay. The resistivity, that's the material property, is just a function of the material that the device is made out of. And a material that is a good conductor, such as copper or really any metal, has low resistivity. It's easy for current to flow through an object that is made from a conducting material. But materials that are insulators, such as rubber or glass, they have very high resistivity, and it is hard for current to flow through them. Here is a table that gives some examples of resistivities at room temperature. And if you look on the left, you've got a whole list of different metals, and all of their resistivities have values that are on the order of 10 to the negative 8th ohm meters. If you look on the right, in fact in the lower right where you have some examples of insulators, their resistivities are on the order of 10 to the 13th or 10 to the 14th ohm meters. That's an immense difference in magnitude. 22, 23 orders of magnitude difference. And so it shows you just how low the resistance will be through something that's made of a metal versus how high the resistance will be when something is made of glass or rubber. Here's an example of a lamp, and the cord for the lamp is 3/4 of a meter long, and it contains copper wire with a radius of 1.5 millimeters. Okay, we want to find the resistance of this cord, right? This 3/4 meter long cord. Well, the first thing I would have to do is to find the cross-sectional area. Since they are giving me a radius, that implies that it has a circular cross-section, and so the area would be pi times the square of that radius. But remember to put that radius into meters, right? We need to work in standard units. And then I'd have to go look up the resistivity of copper to find the rho, and would find that it's 1.7 times 10 to the negative 8th ohm meters. And so anyway, so we find the resistance of this, 0.75 meter long cord is only 1.8 milliohms, very small. And and that's an example of why the resistance of wires in a circuit is often ignored, because the resistance of other components, like for example the light bulb, is going to be so much greater in comparison. Let's go work a couple of examples. I'm going to worksheet 9A. Let's look at number 6. So here we have at a junkyard, they're crushing old cars into cubes of metal, and the cubes are 0.4 meters on a side. So I'm going to try to draw a cube. Let's see if I can do that. Okay, so I've got this block of metal, and every side of it is 0.4 meters. So if I run a wire in here and it comes out the other side, current is flowing in that direction. The length of this device is going to be 0.4 meters. And here on this face of the block, that is the cross-sectional area. And so, the area here is going, in its square cross-section, so it's going to be 0.4 meters by 0.4 meters, or 0.16 meters squared. Okay, so I'm ready to calculate the resistance of this block of metal. It's going to be the resistivity of the steel multiplied by the length of the cube and divided by the cross-sectional area. Okay, and let's see here. It says to assume that these cubes are made of iron. So I'm going to go back to my slides and let's see if we can find the resistivity of iron. Oh, here it is. It's 9.6 times 10 to the negative 8. Okay, so I've got 9.6 e to the negative 8, and that's ohm meters. The length is 0.4 meters, and the cross-sectional area is 0.16 meters squared. If you notice, all of my meters are canceling. I'm going to be left with ohms, and that's good because resistance is measured in ohms. So I've got 9.6 e to the negative 8 times 0.4 divided by 0.16, and I get 2.4 times 10 to the negative 7th ohms. So it's not a very big resistance, that big piece of iron. Let's look at another one here. So here we have a very fine wire. It has a cross-sectional area of very small. This is a very teeny little wire, and it has a length of 1.1 meters, and we want to find what it's made out of. Okay, so we connect a standard battery, 1.5 volts, and we measure a current of 0.048 amps. Okay, so here I'm going to need to think about Ohm's law again. So I know the voltage and the current. I'm trying to find the resistance of this wire. It would be the delta V divided by the current. Okay, so the delta V is the 1.5 volts. The current was 0.048. So the resistance of this little wire is 31.25 ohms. And then I also know that the resistance depends on the material and the geometry, so it equals the rho of the material times the length of the wire divided by the cross-sectional area of the wire. The thing that I'm trying to do, I'm trying to solve for this. The rho will tell me what material it's made out of. Okay, so let me solve for rho. I'm going to get it by itself. It's going to equal the resistance times the area divided by the length. Okay, so we found the resistance. It's 31.25. They gave me the area. I don't have to calculate that. It's 9.4 e to the negative 10th. The length is 1.1. Okay, so let's see, 31.25 times 9.4 e to the negative 10th divided by 1.1, and I get 2.67 times 10 to the negative 8th ohm meters. Let's go see if we can identify what type of material this probably is. So I'm looking for 2.67 times 10 to the negative 8th. Well, that puts it as one of the metals, and I'm thinking the closest one in my list here would be aluminum. And so we're going to, I believe it's made of aluminum. Okay,